Hello, everyone. Welcome to Professor Messer's Live Network Study Group. This is the study group for February 24th every month, and now we're finally to the February timeframe. We've been working on putting together all of your questions throughout the month, and we finally made it to the day. Now, if you're watching us live, this is a live call-in show, so you can join us at professormesser.com/live and follow. There's also phone numbers that you can use there to call into the studio live if you have a question that you would just like to phone it in and ask. I've also got an 800 number there if you're calling in from Skype, so you can call in and use Skype from anywhere in the world for absolutely free to talk to me, ask a question, and maybe even see if I know some of the answers there. We do this every month. We got quite a bit that we're going to do this month, but before we get to the specific questions, I want to thank you for joining us, and thank you for watching this, and thank you for sending those questions. We really couldn't do it without you. You probably are aware that I have my entire Network Plus video training course available to watch for free online, but a number of you would like to be able to take that with you offline. So I have a version of that you can purchase that you could take on a plane or on a boat or just sitting around. You'd like to have a DVD-ROM version that you can pop into a device and put on your big screen television, for instance. I have some folks that are doing that on their Xboxes, their PlayStations, and playing the MP4 files right there. There is also a lot of the things that I do during the week. You can follow what's going on at professormesser.com/Twitter, professormesser.com/YouTube. Just type professormesser.com/something, and if that thing exists, you'll be taken there. It's just that easy. I'm also watching the chat room on the Professor Messer website. If you're here live, there is a live Network Plus study group chat room, so you're welcome to join us there. I'm watching the questions and the things go by. People are saying I should do more of these. Do one in Security Plus. Do some more different kinds, and hopefully one day we'll have enough time to add a lot more live events to what we are doing. We're trying to fit as much as we can into this problem of physics. As soon as I can solve that time-space issue, we'll be in much better shape. As I mentioned, we do this every month. So if you are joining us for the very first time, you may not even realize, you may not even realize there's a lot of information that we went over last week that you might have missed. So if you want to go back and look at the replays are available on the Professor Messer website. The top pull-down menus, there's a link right to the study group replays. And last month, I answered questions like, is there a way to track bandwidth flowing through an unmanaged switch? What's the difference between a switch and a router? Why do we need spanning tree protocol to prevent loops? Do you think it's important to take the A+ before taking the Network Plus, and what is the difference? And I'm taking the Network Plus exam next week. What's the best way to make sure I'm ready? As I mentioned, I get a lot of questions coming in every month. Some of these questions were asked in this month, so I won't be repeating myself, but you can easily go back and look at the replays and see how those questions were answered and other things that you might want to find out about. We answered even more things than that. That's just a smattering of the things we went through. Now, another thing that we do during the study group is I try to involve you, try to make this more interactive. So if you're watching live, you can participate with me as well. I ask questions of you. So what you'll need is either a mobile device. You can pop open a new window in your browser. You can get a QR code reader on your device, and you can answer questions with me. I have some pop quiz questions that we will do later on in the study group, but I have really a question just for general knowledge and to get you familiar with this voting system. You can go to govote.at and go to number 72684, or use your QR code reader, and it should take you there as well. And the first question I have for you is, how long have you been studying for your Network Plus certification? And when you get there, you'll be able to vote in different categories like less than 3 months, 3 to 6 months, 6 to 9 months, 9 months to a year, or over a year. So I want to know from you what you are doing with Network Plus. Some of you are just starting in with the Network Plus settings and configurations. Others of you are been doing this for a while. You maybe stopped studying and then you're back to studying again. I'd like to get a feel for the folks that are watching and what you're doing there. In the chat room, I see a lot more folks are joining. Thanks for joining us there. Hello, everyone, and good morning or good afternoon. When we are looking at a lot of the things that we're going to do today, it's going to involve your questions. So we probably won't be able to get to everything, but I've noticed a few things that have come up in the chat ready, we will be discussing some of those things. There's a number of questions I get constantly, and sometimes I hit on those during the study group as well. And of course, if there's something specific, you can always call in and we can discuss it there as well. Well, if we start to look interactively at the answers that we're getting in about how long you've been studying for your Network Plus certification, this is how it tends to go, where you have a lot of people in the 0 to 6 month time frame, and then in some ways it tapers off. Occasionally I'll see that end over a year begin to creep up. There we go. We got another vote there for over a year, and you can start to see that creep up there as well. I think what I usually see is that there are classes that take the Network Plus certification, and so when there is a semester that begins and ends, I can kind of see that in the graph itself. There are others of us that are professionally like to do these things as well, and from a professional perspective, it becomes a bit more of a challenge to keep the time, find the time to be able to do those things. That can be a challenge as well. I think that that when we start working with technology in general, it's a challenge. But the Network Plus certification, as you've probably seen, has a lot of nomenclature, a lot of words you have to know. And when I get into start reading through these things, it's a lot. There are a lot of abbreviations, a lot of different things you have to understand about it. There is a lot more to know with, at least from that naming convention and abbreviations in the Network Plus than there ever was in the A Plus. And in fact, I say the Security Plus probably has a good chunk of that as well. The Network Plus really focuses on those abbreviations and see what's there. The idea is we want to be able to go through these and understand more about what we're doing, and hopefully we'll be able to do that on the study group today. Now, I have also some other things that might help you, and one of the things that I put together is a piece of information that can help walk you through, because the Network Plus certification has really not been around. This latest version's only been around for a few years now. We usually see these things rotate through every 3 years or so. So probably later on this year, beginning of next, we may see a new version, but there's usually an overlap time when that's occurring. You can see the current Network Plus was released on December the 1st. There was a overlap period that went into 2012. So you can imagine the 2015 timeframe will probably see this particular version retire. So for those of you that sent me questions wondering, when is this going to retire? Am I in danger of studying for something that's not going to be available any longer? You don't have to worry about that, because you've got plenty of time before this particular Network Plus version is going to go away at all. And I think what you'll find is when it does change from this 005 version to whatever the next version is going to be, it's a pretty close change. There's not much different between those two. So you're probably just fine from that perspective as well. There is quite a bit that you have to know in the Network Plus, and they expanded it out to include a lot more security. There's virtualization information on the Network Plus certification. There is quite a few things. I also have, for those of you that have seen this on my website, a study guide. This is an 11-page study guide that takes all of those pieces of information from my all of my slideware, all of the things that I show you on the screen, because I've created traffic maps, I've created diagrams, I have all of these pictures that I've taken, and I wanted to make them available for you to look at on your screen as well. So if you were to go to my website, you'll see that I have a PDF file that takes all of those things that we have to know. In fact, here's all of these ports and protocols, for instance, that I document in the study guide, all of the diagrams that I've created, the DNS resolution process, the network troubleshooting process. It's all in this study guide. So if that's something that interests you and you'd like to be able to take advantage of those, it's $10. You can get it from the website. There is all this and so much more inside of that study guide. I tried to put everything I could inside of that, make it available to you. And it also goes to help keep the website running. So it's nice to be able to help support what we're doing here as well. And it's been really a great response from you. I've had this study guide out for a few months now, and I appreciate everyone who's purchased the guide. I get great feedback from you. Thanks for that. And for those of you planning to take your exam, it's something that might help you as well. So if you've started to look at some of the things that we are doing today, we've got quite a bit that's going on. We'll talk a little bit about the exam Q&A in a bit. There are a number of things that we will talk about But first, I have a question for you. Again, we're going to go back and I'm going to try to find some of these questions for you. And the first one I have is more of a pop question about IP addressing. So get your QR code readers ready. Do not answer in the chat room. No giving the answer away in the chat. So here, the question is, which one of these is a private IP address? And when you visit this page at govote.at and you put in 891445, you will have a number of options available. And I'm not going to say them all there. You'll be able to go to the page and we'll look at them in just a moment there. But you need to pick through all of those and determine which one of these is a private IP address. This is, in fact, for the one that we have here. There's quite a few. I've got 4 options there for you. So have a look at that. Click over to govote.at, the number again, 891445, or just click your QR code reader to go to that page and see if you can figure out what this happens to be. One of these is private. And so first you have to know 2 things. You have to know what is a private IP address. And the other thing you have to know is what range of IP addresses would qualify as that. So it's really a multiple step question to get you into the answer for this. I've got quite a few here on the screen. Which one of these is a private IP address? There are actually, for this one, I have quite a few different options here. This one's a pretty good one to have there. I think there's quite a few things to look at. I'm going to flip over to the screen that shows you what those are so you can see what those look like. So we have to figure out which one of these is a private IP address. No cheating, no Googling. You have to figure this out on your own to go through there. You've got to go through the paces yourself and figure out those. We've got 22 responses so far for the private IP addresses. And I can't wait to see what the risk, because I can't see them either. I see what you see on the screen, 27 responses. There is quite a difference between a public and a private. And one of the questions that came in was specifically about this, and we'll look at it in just a moment. Well, we've got about 28 responses in, 29, get those in. No more bets, 31 responses. Here we go. Let's look and see what the answers or what the responses were from you. Oh, looks like I got a smattering of responses from you on private IP addressing. I like it sometimes when I can mix things up enough that people are thinking, what are you talking about? What are those things? So only one of these addresses truly was the private IP address, and yet we've got kind of a mix. Some people are saying some numbers, some people saying others. We'll come back to the answer in just a moment. In the meantime, let's look at this question that was sent in. I think what we're about to see is going to answer the question for us. Then we're going to flip back and see what was really the answer. So you can still vote there if you want to still go back and vote on those pieces at 891445 on the website govote.at. Well, the question that came in was from Fatal, who said, how does a public IP address and a private IP address work? What is that? What are these things? And this really goes back to the beginnings of the internet, the beginnings of IP version 4. And when we started creating these IP addresses, we realized very quickly that we were going to run out of addresses because of the popularity of all these devices that were connecting into the network. And so we realized we needed to create some blocks of addresses that we would only use on the inside of our private network, on our organization's network. We wouldn't use these addresses to connect to things across the internet. These could be used in our private network, and then we could perform network address translation to use a public IP address on the outside. Because the only way you can connect to someone over the internet is through their public IP address. And if you're using all the private IP addresses, the only way to communicate on the internet is to translate it in some way. And we're going to talk about network address translation in just a bit. So there is a list of these. And if you went out to the internet, you'd be able to go to an RFC 1918. It's one that comes up quite a bit, that lists out what all of these blocks of private IP addresses are. And everybody can use these private IP addresses. They can overlap because they're private within your organization. It's very, very common for organizations to use things like the 10 dot network, 10.0.0.0 through 10.255.255.255, and the default subnet is a /8. But you can, of course, subnet even further. It's very common when I walk into large organizations that they are using an IP address that starts with 10 dot something. We commonly refer to that as the 10 dot network because everything after that could be any number you'd like, and they will commonly subnet it with 24 subnet bits. So it might be a subnet mask of 255.255.255.0. Once you have that 10 dot address, you can split it up however you'd like. It's your private address to do as you'd like. Nobody's connecting to that address and connecting to you across the internet, so you can do whatever makes sense for you. There are also other blocks that you can use, 172.16.0.0 through 172.31.255.255, which means the default mask that's being used there is a 12-bit mask. And you can, of course, split those up into be what is called 16 contiguous class Bs if you were going to talk about this in a class-based mode, but you've got 12 subnet bits. You can really subnet further down the line as much as you would like. The one that we commonly see on our home routers, if we were to go to a big box store and we purchase a wireless router that we use to connect to our DSL connection, our cable modem, or whatever the ISP connection is coming into our network, we very commonly will see 192.168.0.0. So it's 192.168.0.0/16. So there's a good example of how you can take any one of these numbers and use them privately on your network. This is why whenever we start looking at numbers and trying to match these things up, we need to find these private IP address ranges. So knowing that anything that starts with 10, anything from 172.16 through 172.31, and anything that's 192.168 would be a private IP address. So with that in mind, let's look and do our sanity check here. So we have 192.166.150.133. Well, we know that 192.168 dot anything would be private. So this is not a private IP address. This is a public IP address. Those 12 of you, not quite correct. So let's do 172.168.22.5. I didn't fool very many people. That is also not within the range. Remember, our ranges are 172.16 through 172.31. This is 172.168. See how I threw that 168 in there? We're so used to hearing that 168 number. 172.16, however, does absolutely qualify as a private IP address. It fits right into that range, 172.16, and then anything after that means it's a private IP address, and 11.192.168. I put the 192.168 in there just to throw you off. And so very simply, it starts with 11, and 11 dot address is a public IP address. If you answered 172.16.30.222, you would be absolutely correct. So congratulations for you 11 folks that were working on that piece. You did a very good job. And I bet if I asked the question again, I bet that you would get it absolutely right this time, because now you know the difference between the public IP addresses and the private IP addresses. Well, I kind of answered the next question for you before I get into the specifics. But before we go to the next question, I want to see if I can get a caller that's in. We have the 559 area code. Caller, are you there? What's your name? What's your question? Are you there, caller? Oh, I don't hear any noises from 559 area code. One of these days, I'm going to get my own call screener, and my call screener is going to be able to run these things down for me and figure out who's on the line before I pick up. That person may want to try calling back. You're certainly welcome to call back, and you may want to call the nice Skype lady. If you're calling in via Skype, there's that Skype testing service where you simply talk in and it repeats back to you what it hears. That way you can be assured that everything you're doing is working properly on your side. So while we're waiting for others to call in, remember those call-in lines are right there. Let's look at another question I have for you with your QR code readers. Don't answer in the chat room. Maybe you've already forgotten what I told you, because the question is, what is NAT? The question is, what is NAT? You go to govote.at to 895433, and I've put some options in here for you of what NAT can be. It can be a conversion of an IP or port. It can be a firewall filter. It can be vulnerability detection, dynamic routing protocol, or a patch management tool. It can be one of those. I suspect there's not going to be a lot of wrong questions with this. So have a look and see, what is NAT? And go to govote.at to number 895433. And you can, of course, go through and figure out what those options might be and vote on those by opening that piece up as well. There's a lot to do, or a lot of things associated with NAT. We're going to go through and look at what these natting pieces are, what those differences are, and some of the things that we're doing with that piece. I think when we start getting into it, you'll find that it's a concept that seems difficult at first, but then once you start laying things out, it's not really that bad at all. I'm going to give folks a few more seconds to get in there to determine what is NAT. There's a few options there. Those options, again, a conversion of an IP or a port. You've got, here we go, we've got a firewall filter, vulnerability detection, dynamic routing protocol, or a patch management tool. So vote on those pieces. We've got a lot to choose there. I think that when you start looking at it, you may just think back a few minutes. You're probably going to get this one just fine. Okay, 28 responses in or so. Let's have a look, maybe what some folks are seeing on this piece. 29 responses. Let's go ahead. I have a feeling I'm not going to fool very many people with this one. Indeed, 19 of you said conversion of IP or port. I think we can go with the audience on this one, that indeed, taking an IP address and translating it, performing a network address translation, implies that you're taking an IP address or perhaps even a port number, translating that and sending it out. Generally speaking, we do this to send it out to the internet and back, but you can do network address translation really anywhere within your organization. There's also, you can see a few folks said firewall filter. Nope, not a filter, although network address translation is commonly done on a firewall. Can be also done on a router, but generally in organizations and perhaps even on the router you are using, the firewall that you're using is also combined with the router, and it's a NAT, and it probably does other things as well. Generally, it does happen on a firewall, or certainly can. NAT is not vulnerability detection, so that doesn't qualify. Network address translation is not a dynamic routing protocol. The dynamic routing protocols are what you put on a router. You effectively turn on a switch inside of the router that says, I want all you routers to talk to each other without me getting involved. You all communicate using your own special protocol, your own language, and you figure out who's out there and where those networks are so that I don't have to manually type in or statically assign routes to be able to get from one side of my network to the other. And to do that, we turn on these dynamic routing protocols in the routers, and they just all talk to each other and figure it out on their own. If a router has a problem, if you have a network break, the routers recognize that you lost the route, and they all perform a convergence process and figure out the best way to route around you or route without you. There is a lot to dynamic routing, but network address translation is not a dynamic routing protocol. RIP version 2, version 3, OSPF, BGP, EGP, those are EIGRP, those are dynamic routing protocols. And it's not a patch management tool. So good job with those. You got quite a few. It really didn't fool anybody with that one either. So you've got a few things to step through when looking at the network address translation piece. And I think it'd be worthwhile perhaps to break down then what the differences are between those two things. But before we do that, let's see if we can go back to the 559 area code. Are you there, caller? I hear noises now. 559, are you there?
Yep.
There he is.
Hello?
Hi, what's your name and what's your question?
Hi, my name is Hansel. I'm calling from Guyana. What I would like to know is within Network Plus, when you take the exam, if you fail, do you have to pay to write over it?
It's a common question, especially since the Network Plus exam is not very inexpensive. Now in Guyana, how much does it cost to take the exam?
Around 50,000.
Okay, so there's an investment to make in that. And if you're wondering how much it costs in your particular country or watching this from other countries, there is a place you can go on the CompTIA website that does explain what the differences are and how much they cost. If you go to the website, here it is right there. I'm on certification.comptia.org. There's a section under training and testing that does give exam prices, and you can simply go to the exam you would like to take in Network Plus, and it goes through all of the differences in all of the different locations and things you would have to purchase and the prices for all of those. In Indonesia, it's 2,427,748 of IDR, whatever that Indonesian currency is. Sounds like a lot, doesn't it? Well, in many ways, I bet it is a lot. It's not inexpensive to take the Network Plus certification. And if you were to look at it, one of the things that you'll see on the exam policies, let's see if I can find the retake policies, is that every time you take the exam, you have to pay to take it. Whether you passed it or not, if you failed it the first time, you have to pay to take it again, unless there is a bit of a stipulation there. There are, when you're ready to take the exam, you purchase a voucher from CompTIA, and you take that voucher to Pearson VUE or whoever the testing center is in your particular area. I believe internationally it's Pearson VUE for CompTIA, but that may be different internationally. You'll have to check locally. When you purchase the voucher, you can purchase a voucher for one time, take the test. But sometimes, for just a little bit extra, they might offer you a voucher that you can use for a retake. So if you take the wrong, or you take the exam and you don't pass for some reason, you've at least got a way that you could retake it and not have to pay anything extra. But you have to plan ahead to do something like that. Now, there is a certain policy associated with the retakes as well. And I think this policy, I'm not sure, I've seen different versions of this policy in the CompTIA website. So we're going to look at the one that's there right now on the main links that say if you fail your first attempt, there's no waiting period between the first and second attempt. But before you take the third attempt or anything after that, you have to wait 14 days. So that's another consideration that you have to think about when taking that exam, is that you may not be taking it. You might fail the first time, jump right in, and maybe you fail the second time. Now there's a waiting period. It's probably best anyway to do something like that. But go through, check with CompTIA, see if you can either get a voucher that is for that single test, or see what the prices might be to get a voucher that provides some replay or retake there as well. If you feel like you're just not as comfortable as you could be going into this, that might be a very good option for you to be able to do that. That's a great question. Thanks for the call. We have some different pieces in there to look at for the vouchers. There's also some voucher discounts available. If you go to professormesser.com/vouchers, there's a 10% discount. So you may be able to try some of those codes internationally to even get the price down a little bit more. There's all kinds of ways to get the best deal on those pieces. And Justin was nice enough to say that was an Indonesian rupiah, an IDR. So we learned something today, didn't we? It's not all about networking. We now are financial experts in being able to deal with those things. Let's go to that question then that was sent in by Jeremy this month, who said, what is the difference? What's the comparison of PAT versus NAT? There is quite a few pieces to go through in trying to determine these words. As I mentioned earlier, when we go into this, there's all these words we have to know with PAT, and NAT that's a great example of those things. As I mentioned earlier, NAT is network address translation. This is where we are taking an IP address and converting it to a completely different IP address. Now, there's a lot of reasons to do that. And it's not just IP addresses. You might be translating a port number and translating it to a completely different port number. Maybe you're not even changing the IP address. You're just changing the port number. Maybe you're doing both and changing both the IP address and the port number. Usually this happens when it's going through a device, usually a layer 3 device, a router, a firewall. And as it's passing through, there's some logic that we put into the device. We tell the device, if we're seeing traffic from this IP or this network, change it in a particular way and send it out the other side. So you're making quite a few manipulations to that piece. There is many ways to do address translations. For many devices, especially inbound, We might use something like a one-to-one NAT, a one-to-one network address translation. You might think in a way that you're doing this if you're hosting a web server on the inside of your network. As I mentioned, we might use internal IP addressing on our servers and on our devices. And obviously, you can't connect to that device over the internet if you're using something like a 10-dot address. That's a private address. You can't hit that from the internet. If you were to send out a request to the internet to please connect to a 10-dot network, the very first router it gets to would drop that because there's no path to the 10-dot network. That RFC has already said that we're not routing those. You can't get it through the internet. Sorry. So one of the things you can do is perform or tell your router or your firewall to perform a network address translation so that your web server has an external address on the outside of your router or the outside of your firewall. And you can tell that firewall, if anybody's ever coming inbound to that IP address, convert it to the 10-dot address, translate it, perform a NAT, and translate it to the IP address of my web server and send it on down to the inside. At that point, when the web server responds, there's already a table built for that. It reverses the process and sends it out. So that's sort of like a buffer, if you will, a translation point between the outside world and the inside world. Allows you to do pieces like that. Now, the question that comes up a lot is this term called PAT, or port address translation. PAT is a NAT. It's a specific kind of NAT. It's a way that we describe a particular way of performing a network address translation. Some people might also call this a source NAT because what you're doing is translating a source address. As I mentioned, we have that web server we just talked about when we referred to people coming inbound to the web server. But what if you're on the inside of your network and you need to talk out? You've got a 10-dot address and you can't talk to anybody unless you're talking out a public address. So one of the things that you can do is tell your firewall or your router, if anybody from the inside needs to talk to Google, they need to talk to Yahoo, you need to go to YouTube, you need to talk to Facebook, and you see this 10-dot address come in, translate that address to my single external IP address. Now, you can start to see there might be a conflict there. Everybody's being translated to this external address. So what if more than one person wanted to talk to YouTube, wanted to talk to Google? We would all use the same external IP address? And the answer is yes. But there are ways that you can differentiate between the two of you who might be going to Google at the same time. And you do that by not changing the external IP. And so that instead of having separate external IPs for everyone, you all have a single external IP, but you change the port number that's being used on the outbound. That's how you would differentiate. We call that a socket. That combination between an IP address and a port number is a socket. So you would have a unique socket, even though everybody's using the same IP address. That unique socket is simply changing the port number. It's a port address translation, and that's why you commonly see that referred to as a PAT. If you have a router in your house that's a wireless router, a wireless firewall, or a wired firewall or router that's connecting to your ISP, it more than likely is performing a port address translation, or as we say here, a source network address translation that's going out. There's also destination NATs. We can also do that as well. It's the reverse of that, very similar to the destination address that we had changed on the inbound to that web server. That's commonly called the reverse of that, a destination NAT or static NAT in that piece. So how does this look? If we were to look at something like this, how would that port address translation look? And here's a good example of this. So we've got at the very top, we've got a server, we've got some clients, some switches. They're connected to a router or a firewall, a layer 3 device. On the outside world, we have this external IP address. And you know it's external because now we know the difference between a private and a public IP address. That's a public IP 66.20.1.12. That's definitely not an internal IP address. In the inside, we can see 192.168. Just by looking at those two octets, we know that those are private IP addresses. So those are the two things that we worked with today to be able to see those pieces. So what we're doing on the port address translation, if I wanted to send traffic out, I hit this router. The router realizes we need to translate this to the external IP. It changes my address from 192.168.1.221, changes it to 66.20.1.12, sends it on its way, and creates a table to keep track of that. There is the reverse. If you were coming in from the outside, wanted to hit a web server, you configure your router to say, if anybody is ever coming inbound to 66.20.1.14, my external address, and he's coming inbound to 192.168.3.22. What we want to do, anytime he hits that on port 80, translate him to that internal address, because the people on the internet have no idea about 192.168.3.22. That's something that's private. It's inside of our network, but they do know how to get to 6621.14. If you want to layer on some of the knowledge you're getting with your Network Plus, when they perform a DNS lookup of your web server, they get this external address. They hit that external address with their web browser, which is coming in on port 80. This router sees that that external address on port 80 is being hit from the outside. It does a conversion to 192.168.3.22 and sends it on its way to the inside. Whew. Does that whole process. Then, obviously, this device is replying back to the router, and out it goes the other direction. Retranslates on the way out. So this happens every time you hit a web server that's out there on the internet. This is probably happening. I can tell you, if you hit the Professor Messer website, you are hitting an external proxy that's doing a reverse proxy. That proxy is coming inbound to a public IP address. On the inside, I've got other internal IP addresses on the inside of the network that I'm using for all of my servers, my load balancers, and other things to talk to each other. So there's a translation that's going on my load balancer as well. It's a layer 3 device that's performing that network address translation. There's one of these days I should really draw out the design of Professor Messer, just so you can get a feel for how you might build out these web servers and be able to work with them. Because network address translation, if you're working in networking, if you're working in security, if you're doing anything with routers or firewalls, you will be doing network address translation. So it's very, very useful to have that knowledge and be able to work with those pieces and have all of that there. There is a lot to do with NAT. We're going to shift a little bit, go from NAT and talk about wiring and cabling. Let's get down to a lower level of the OSI model. So let's talk about some things. Get your QR code readers ready. And of course, no answering in the chat room. The question I have for you, it's a bit of a mouthful, but it does, I think, talk about one of the questions that I have for you, which is which one of these would be the best choice for gigabit Ethernet in an area of electrical interference. So I kind of added some layers of stipulation there. So let's say you're in an environment that has a lot of electrical interference, and we need to run a gigabit Ethernet connection from one device to another. And I've given you some options. So there's some that you might think about, but the only options I give you are UTP, RG6, STP, Plenum, and RJ11. So there's some options for you. Those are the only options you have. Which one of these things do you choose in this noisy gigabit Ethernet, electrical noisy environment to be able to get gigabit Ethernet speeds and be able to work that through? UTP, RG6, STP, Plenum, and RJ11. You can go to govote.at, and the number is 169641. Now, if you are watching this on the replay, I will tell you that I'd leave these up. So if you wanted to go in and see what the final results were, you could also do that, and you can even vote on them if you'd like to be able to have that piece. Go look at those out there on those with those numbers. I'm going to bring that up so you can see those pieces. There we are. You can go to Gigabit Ethernets, UTP, RG6, STP, Plenum, or RJ11. Vote now. We got 15 responses in. You guys are voting pretty well. I think there's a lot to look at. Now you really have to know your cabling. That's another one of those layered questions. I mentioned I like to give you layered questions with those pieces. This is a good example of that, because you have to know why a electrically noisy environment is important. You have to know gigabit Ethernet. You have to know what cables support gigabit Ethernet. On top of that, cables that might help you in an electrically noisy environment. You have to know what all these things are too. There's a lot of abbreviations again on here, and you have to know what some of those things are. So you've got quite a few things to look at with those pieces. Let's see. We've got about 35 responses in. Let's look at what the responses are. So right there in the middle, 29 of you said STP. And in this particular case, the vast majority of you absolutely correct. It is STP. 3 have said Plenum. Some said RG6, which is a coax type connection, UTP, and RJ11. So very quickly, to go through this piece, UTP is unshielded The electrically noisy part is the part of the question that really talks to be able to get gigabit. Now, you probably thought, just hearing the question, I'll use fiber, because that would certainly get rid of any type of electrical interference. Light isn't going to be affected by electrical interference anywhere. Therefore, we're great. We're going to use fiber. But I didn't give you fiber as in one of the answers. So you couldn't use fiber in this case. RG6's coax does not support gigabit Ethernet speeds. So not really something that would be the best one to use in this environment. It is shielded pretty well, however. So if it would just support gigabit Ethernet, but it does not, alas. Plenum is a type of coating on the outside of either a UTP or STP type cable, or really any cable that you might have. It's a special sheath that is resistant to fire, and it does not create a lot of smoke or toxic fumes. So it's great to use inside of environments where you're concerned about the fire laws, and having your if the place catches on fire, you want to be sure to minimize the amount of toxins in the air and the smoke that's in the air. Plenum is the way to do that, but plenum doesn't help you in an environment that's electrically noisy. If it was electrically noisy and on fire, I guess maybe then it could possibly be an answer, although I'm not sure that we'd be that concerned about running the gigabit connection at that point. And none of you were fooled by the RJ11, which is not a cable, but it is an interface connector type commonly used for modem connections for a voice line type connectivity. It's not even used for Ethernet connections, certainly not for gigabit Ethernet. So didn't really fool anybody, too many of you on that one. Most of you knew it was STP. So the reason I asked this question was really because of what Scott asked. And I think I'd like to pop over and see that. Oh, if I could see that. We can't see right now because my video isn't giving me anything on the screen. Let's see if it does. There we go. We're back. We're going to see if this works for us. It's not good when there's no video. This came from Scott, who said, when is it most appropriate to use STP cable when designing and or building a network? I thought, well, we should probably see how it blinks out. See, that's a problem. I don't know if any of you are familiar with video production, but when there is no video, I assure you that's a significant issue. The way that we look at some of these things when working with it is to be able to break down those pieces. And when would be a good time to use a certain type of cable, a good time to use a different kind of cabling. So we'd like to step through those pieces. So instead of me doing it this way, we're going to do this. This is live television, people. We're going to break this down and maybe hopefully see it a different way. I'm going to bring it up and break this down in a different format for all of us. In the meantime, let's see if we got any calls in. This would be a great time to take a call. And of course, that's not the case. Not going to have one there. I'm going to change the video input so you can see it a little bit differently then. And we're going to, because I've always got a plan B. There's always something else up my sleeve. Let's look at these because I want to break down for you what all these differences are of these types. And I want to show you really close up what the differences are. Now, the question that came in from Scott was specific to using STP cable. So let's break this out a little bit and look at it. So here is twisted pair cabling. This one happens to be unshielded twisted pair. There's no shield in here. We're going to look at one in just a moment that is shielded so you can see it. This uses something called balanced pair operation. That's why you have these pairs going through that are twisted together. One side of the pair has the positive signal. The other side has the negative signal. And what happens is when you send that across the network, it's compared on the other end. And any differences of those two are easy to find because you have a positive and negative side that you can use to help reconstruct the signal once it gets there. And because it's twisted, if there was something that was electrically noisy as the cable's going by, it's not always on the same wire. The wire's twisting around and going away from that at the same time that others are coming towards it, which help a lot when you have these environments and a long run of Ethernet that allow you to do that. That's why some of these cables is kind of hard to see in this picture, but there are different twist rates in these. This happens to be, this is like maybe a Cat 3, maybe a Cat 5. When you get into even the higher categories, there's even tighter and more significant twists between the two. We might have one of these that we can look at on there, but because there's different twist rates, we also can get different signals, even if that electrically noisy piece has affected the entire cable at one time. Really ingenious in the way that we've planned that. And if you've never really looked at the end of a twisted pair cabling, you may not have even realized that it's there. So here's the difference between shielded and unshielded. You've got this shielded twisted pair that's in place with the STP. That's certainly going to protect you against interference, and you can kind of see, you zoom up on that, there's the shield inside of it that's wrapped around the cable. So it's this metal or metallic type shield there's not metal. That certainly can be. In the case of coax, it actually is a piece of metal that's in there. You'll also commonly see things like this ground connection. There's a separate ground there, so you can ground the connection on one end of the link. So that helps to often minimize electrical signals as well, because you have a ground that you can work with. There is also unshielded twisted pair. Let me plug my video back in here before I forget. Of course, it fell on the ground. So we'll get that video up and running. The unshielded twisted pair doesn't have that shield in it, doesn't have that ground wire that's out of it. You'll also notice that the shielded twisted, it's funny, out of the bottom. I didn't even mention that. It's a little piece of nylon, some grouping of nylon in there. Anybody in the chat room know what that nylon's used for? I bet some of you do. I bet some of you are familiar with wiring and being able to use those. You don't see the nylon on this one, but sometimes you'll see it on an unshielded twisted pair as well. It is called a ripcord, so that you can pull on that nylon and it will pull down the length of the cable and allow you to pull the wires out without ripping them open or slicing into it with something sharp that might damage the other wires inside of it. So that's a very common way to go through the process of pulling out and making the cable getting at the wires a little bit better, and you didn't even have to get a piece of a knife out or something sharp to be able to get into that. You don't see that in all cables. Sometimes that's an extra piece that you would pay for, but it does come in handy. I certainly could take advantage of some things like that as well. There's also, if we flip over, we can get a tight shot of the unshielded twisted pair. See that piece in it? There's quite a bit there. We've got also inside of this, we look at the cables themselves. We break out on the shielded. We've got a lot to look at there. Now you can really see the ripcord and the ground wire and those pieces. Really got a lot that you could do with those. Now there's another type of cabling, and it was actually asked in the original question from Scott. And I think he was really talking about shielded and unshielded, but another part of the question that came in from someone else as well is one that talked about Ethernet cabling that wasn't twisted. There is a type of flat Ethernet cabling that you will find. This flat cabling, you can see there's no twist. In fact, originally the Cat 3, maybe earlier than that, this whole idea of the Ethernet connector was designed for this flat cabling. This was not 3, it was before that. I think this was for voice wiring. So you could simply just slide the wire right in and crimp it. And if you've ever done cabling with Ethernet, you know you have to pull out all the wires, you have to straighten them out, you have to cut them to the right length, you have to get them into the connector and crimp them. So you have to even put them in the right order. Sure would have been nice if it was flat and we can just slide it right into the connector and crimp it. And in the old days when you were doing just voice and some 10 megabit Ethernet, you could get away with these flat cables. Sometimes you'll see them referred to as a silver satin cable because that's the type of silvery substance on the outside of the cable. But because we went to these higher speeds and we needed that twisting of the cable to help minimize the amount of noise, well, that was something that meant we couldn't use those flat wires anymore. You don't see the flat wires listed on your Network Plus exam. You probably shouldn't be using them for any very long runs in your network. You could probably get away with it with just a patch going to the wall, but even then it would make a lot more sense to keep everything in a Cat 5, Cat 6, or at least up to a twisted pair category rather than using something like this. Now for voice, if you ever looked at your RJ11 connections, voice uses that flat type of non-twisted cabling. So that's because voice doesn't need the same requirements that something like a gigabit Ethernet connection might need to use. And that's why we have the twists, and that's when we would use shielded, and that's when we would use unshielded twisted pair as well. Well, there's a lot to talk about as far as the exam itself and how it works. But before we get to that, we've already had a few folks ask about this in the chat room, and that's around the Network Plus and the performance-based questions. There are, for those of you that are just getting into the Network Plus certification, there are a number of questions you will be asked at the very beginning of your Network Plus certification, and those questions are going to ask you about things that will require you to perform a particular function. Maybe you're going to have to put things in its particular order. Maybe you're going to have to perform some networking troubleshooting at the command line and get that network troubleshooting to work. Well, for those types of connections or those types of questions, you have to know how the network operates. You have to understand DNS. You have to understand ARPs. You have to know how to do a trace route. And it may not be something that you can do on your own machine. So the folks at GTS Learning, friends of mine that have put together these live labs that take you through scenarios where you can have all of this equipment all set up in the cloud. It's all on the internet. And you can step through and use some of these technologies to step through troubleshooting tasks. There are entire labs set up that take you step by step through every piece of it. And I have some of these live labs on my machine. I'm going to pull one up and let you see it in just a moment, because there's an entire huge group of a virtual environment out there in the world that you could start taking advantage of and be able to use these pieces. And so you don't have to have computers at your home. You don't have to have separate operating systems. You don't have to have a router. You don't have to have a firewall. You don't have to have something that does NAT or change any of the things that you have that perform NAT. You can simply go to your configuration, your setup. There we go. So here's the live labs. I can go to, here's one that's configuring routing. So we talked about, I don't have a router. Well, they do. And it's all set up with the lab diagram that you can see on the left side there. I've got devices on the right side. On the left side are the devices, and I can power on my server, my client, my gateway, my router, and I even have a web server in here with the LAMP stack to be able to work with those pieces. And it boots up all of these machines. And now I can go down to the bottom and step through the lab. Step number 1. What do you do? Well, there's 3 networks. Here's the network settings. Here's the routing configuration. How would we see the routing? We would step through it in this way. We bring up Windows. We click on these pieces. We go through those steps, and all of those routes are there. Now, we can go through this entire lab now and be able to step through all of the pieces as if it was all of these devices sitting in our own house, just like it is right now. It's in my studio. So my gateway has already been configured. It's up and running. Here's the gateway. It's automatically establishing connection. I'm running this on Chrome. So I have now a remote desktop connection using HTML5. So I didn't even have to load up any extra software. It just popped open a new window and loaded the remote desktop. And then my server's going to boot. There, my server's just been done. So it's now finished. I can now connect to the server. So my server's up and running. So now here's the server connection. So I can bring up all of these on the same screen, start working with them. A lot of great capabilities there. And another nice part about it is you can get a free 1-hour sample of this. If you go out to professormesser.com/netlabs, try it for yourself, see if it works for you. I've also got special pricing there from GTS Learning. For $99, you get the entire set for a year. So you can get on this virtually. You can go through every one of these labs and spend as much time as you'd like for that $99. Really nice to be able to have some of that flexibility. So we appreciate seeing that from our folks at GTS Learning. Maybe it will help you as well. Go try that free trial and see if it does. Well, I get a lot of questions about the Network Plus exam itself. So I wanted to step through some of these because these aren't necessarily technical questions, but they could help you as you are taking the exam. So let's step through what some of those pieces might be. One of those is, can CompTIA certifications help me get into college? Now, the the challenge of getting into a college, and I'll speak specifically about the United States, higher level universities, college and universities in other countries works a little bit different. So somebody does have some knowledge about how these things work in other countries. We would be glad to take your call. One of the things that we are concerned about in the United States is that you have to apply to get into a college or university after you finish high school, after you finish the 12th grade and you graduate from high school. And the college is usually looking at your grades, and they're also looking at other things you've done, extracurricular activities, or certain knowledge that you might have. So this would be a great place to put. Here's some work experience that I've had. Here's some letters of recommendation from my principal at my school. And here are things that I've done to further my knowledge of the world, of technology, and a certification could absolutely fit into that. Now, I'll tell you that the CompTIA certifications are specifically designed for people who are working in IT or that are just getting into IT, at least with the A+ and the Network Plus side. But I think that one of the things that can absolutely help and at least show initiative is to have those certifications in your pocket. I don't think it's required to get into a college or university, but I think if you had that as part of the letter that you're sending in or the package that you're sending in to get into a college or university, that could be a great thing that can really help. And interestingly enough, now you can keep that certification always relevant. You may not even have to take the exam again, because being in college means that you're taking classes that would count towards the continuing education units. So you really don't even have to keep up with those very well. You pay your annual maintenance fee and you keep your certification by the time you get out of college. Now you've still got your certification. You can go go to that job and get that interview. And for people that are looking for the CompTIA certification as a prerequisite, now you've already got it. So you've got some options there, and it certainly can't hurt to have that there as well. Another question that came in is one about the structure of the Network Plus certification, and I think that is one that I get all the time with the CompTIA study groups that I do. One of the questions that comes in quite often is, how is the Network Plus exam structured? What questions are going to be asked the most on the exam? What things should I absolutely study for the Network Plus certification? So I say this in every single study group, but it's incredibly important that you download the exam requirements. And I'm going to show you right now how you do that. If you've not done this, you should do it right now. You should pop open a new window. You should go to certification.comptia.org. Right at the top is the Get Certified option. I'm going to go to Network Plus. And right there at the top, under CompTIA Network Plus, it says View Exam Objectives. It also says View Sample Questions. Another popular question that I get is, where can I get some sample questions? They have them on the CompTIA website. Let's view the exam objectives. It's going to ask you for information like your name, like mine. And for those of you that want to email me, james@professormesser.com. And I'm going to put that I am in the United States. It already selected the Network Plus certification for me. I'm going to get those exam objectives. I want to get the latest ones, the N10005. It's very common for CompTIA to leave up some of the older objectives here. And I can only guess they're doing this because a number of people may have stopped studying on the 004. Then suddenly they find there's a new exam, the 005, and the question that comes up is, what is the difference between those two? You could download both of those and do a comparison yourself. In our case, I'm interested in the English version of the 005. If you're in a different country, you can certainly do that as well. And because I am running Chrome here, it does bring it up on my screen so I can show this PDF without a PDF reader. So here we go. So if you're running Chrome and you're running maybe a latest version of Firefox, you can do that. Here are the different things that will be asked at a high level. Network concepts is 21% of the exam. Network installation and configuration is 23% of the exam. Median topologies is 17% of the exam, and so on. But if you scroll down a little further, they do tell you that this is not an exhaustive list. They could ask you things that aren't in this list, but they pretty much ask you what's in this list, because there are pages and pages of bulleted items, numbered bulleted items of all the things you have to know to be able to pass this exam. If you memorized and knew all of these bullets, you would do fine. Even if they asked you something that was not in this list, there's no way that it's going too far off the mark, and they certainly wouldn't be asking you many of those. They even tell you, here, identify common TCP and UDP default ports. They give you the exact list of protocols and the exact list of port numbers that you have to know for your exam. You don't have to know more than this. You shouldn't know less than this. You should know exactly this number. They will not, or generally they do not, go beyond the scope of what you have on this list. Occasionally you might find that they do. Sometimes they ask questions that aren't graded of things that aren't in this list. So if you do see something pop up on the exam, that wasn't in my exam objectives, you may not actually be graded on it. They do tell you that at the very beginning of that piece. Look at all this detail. It's very unusual in a certification exam to get this level of detail. So take advantage of that. They give you an enormous checklist before you walk into the room. You can check off exactly what you know and circle the things you don't, and be able to go back to your books, go back to your study materials, watch some videos, and learn more about the things that you don't feel 100% comfortable with. That way you're going to be in very good shape when you start working with those pieces. I think that's the thing that makes the difference to me, is knowing exactly what you should be focusing on. That's where the difference is going to be. I think that's where the focus should be for the things that you're doing, is finding out exactly what is going to be asked of me. And that exam objectives is just a great way to do it. That's what I use. When I take an exam, regardless of who the exam is from, I always go back and find the exam objectives and use those as my checklist. So it's very useful to have that there and be able to work with those pieces. Well, I have another question for you. This will be our last question of the day. So get your QR code readers. And this one is more for me. This is, you get to tell me what you'd like to see next time on the Network Plus study group. You can go to govote.at and go to 826815, and you can send me information about what you would like to cover. And this gives me an opportunity to hear from you on what topics we just didn't get to today. There's so much information. What should we go through next time? What pieces should we really focus on? Sometimes we take calls the entire time. Sometimes I talk about information that I have the entire time. Sometimes it's a mix of those two. But I like to find out the things that are top of mind for you and that are important for you to be able to take advantage of. You can, of course, always throughout the month, send me an email, james@professormesser.com. Also at the top of the Professor Messer website is a Contact Us link. You can always click that Contact Us link. There is also, if you're watching this for continuing education credits, I need to be able to certify that you've seen it. So one of the things that you need to send to me is an email with the code word NAT, N-A-T. And if I get that from you, that tells me that you've watched the entire thing and that you found that code word that I said inside of that. And that way I can certify and send it back to you. And then you can send that certification on to CompTIA to be able to get continuing education credits for this particular piece. There's a lot of things that I like to get from you, a lot of information that helps me as well. So if you are watching this on the replay and you'd like another way to send me those details, you can, of course, go to govote.at and vote on this piece. It's a free form. Just type, fill in the blank of the things that are important to you. Some of the things that have come in are regarding subnetting. There's not a lot of subnetting on the CompTIA Network Plus exam. It's really more high level, but that might be something we go through. The OSI model in depth. We haven't done a good OSI model overview in quite some time. That would be another good one to do. Ethernet topologies, authentication and security. There is a little bit of that on the Network Plus certification. We talked about some a couple ago, so it's about time to go back into those as well. Firewalls and other devices might be a good overview as well. So these are all good recommendations. Keep sending those recommendations in. I absolutely go back to these before I build the new set for next month. I go right back to this screen. So even if you're watching on the replay, put it on the screen. I will be able to see that before the next Network Plus study group. Now I've got a lot of things before we finish up the main part of the show. If you're watching live, we do an after show, so I stick around for a little bit, but this is the time where we sort of shut things down a little bit for the main part of Network Plus anyway. If you'd like to learn more, see more of that study guide I mentioned, you can find it at professormesser.com/netsg for Network Study Guide. You can, of course, find all of the Network Plus videos on YouTube or on the Professor Messer website, professormesser.com/YouTube/Twitter/Google Plus, even Facebook. It's all out there. You can find me at those pieces. Again, thanks to GTS Learning and the special pricing they have of their live labs that you can find at professormesser.com/netlabs. And of course, thanks to you, I wouldn't be able to do this study group without having you here and be able to take advantage of all this knowledge you have that says, let me know these questions that you're sending in. And I think it makes for a great study group, and we'll just keep doing these month after month. Without those questions, we'd never be able to do it. So thank you so much for sending those in. Thanks for all of your support. Thanks for emails. Thanks, everybody in the chat room. We'll see you next month on the Professor Messer Network Plus Study Group.